all those sample means are not necessarily created equal, because if you notice the numbers, there are some sample means that are closer to the true population mean than others. Remember that that true population mean was 68. Okay, so if mu was 68, the sample mean x bar that was closest to the mean 68 is 67 when we sampled C1, C2. The sample mean x bar that's furthest from the population mean 68, the one that's furthest away, if you take a look at the numbers again, the one that's furthest away from 67 is 102. Okay, so if we happen to sample using, let's see, 102 was right here, C2, C4. If we happen to make a sample where our two data values sampled were 84 and 120, and we found the sample mean 102, and we use that sample mean to estimate the true population mean, we wouldn't be too close. Okay, there is something called a sample error that's associated with each and every sample mean. A sample error, or sampling error, is the difference between the value of a sample mean and the population mean. And we have this formula, x bar minus mu. If we take our sample mean and we subtract the population mean from it, we get a sampling error. So let's calculate the sampling error for 67 and 102. So if we take 67, x bar equals 67. To find the sampling error, we simply take x bar minus mu. So we take 67 minus 68, and that gives us a sampling error of -1. Now that -1 is negative because 67 is on the left side of 68. Any sample mean that's less than the population mean will have a sampling error that's negative. To find the sampling error for 102, we take the sample mean 102 and subtract the population mean 68, and we get 34. Okay, so it's a positive sampling error indicating that 102 is on the right-hand side or greater than the population mean 68. Now, if you look at the absolute value of the sampling error, it gives us an indication of how far that sample mean lies from the population mean. We're going to calculate the sampling error for all the sample means and put the values in the fourth column of the table. So on your handout, in column 3, you put all the possible sample means. And in column 4, you're going to calculate the sample error for all those sample means. So we just completed the sampling error for x bar equals 67 and for x bar equals 102. Now find the values for all the sampling errors for all the other sample means. So you could pause the video, and when you finish it, here are the answers. Okay, so the sampling error, some are negative, some are positive, because some are below the population mean and others are above the population mean. The absolute value of each of these gives us an indication of how far away from the population mean that sample mean is. So let's recall again this whole process. We have a population of 5 commuters. We took samples of size 2 from the population, and these were all the samples of size 2, every possible combination. For each of those samples of size 2, we calculated the sample means, which are all values for x bar, for all the possible samples. And this column became something called, this collection of numbers is basically called the sampling distribution of the means. We calculated the sampling error sampling error by simply taking the sample mean and subtracting the population mean. Now this column, the sampling distribution of the means, it could have been created from samples of size 3 or samples of size 4, or if you're working with a big population, it can be constructed from samples of any size. But each of the possible samples have got to be the same exact size. So suppose your population had 20 data values and your sample was going to contain 5 data values. This first column would have all the possible combinations in which you can create samples of size 5 from those population of 20 data values. And again, this column, the sample means, would be all those possible sample means. So the column sampling distribution of the means is a collection of all the possible sample means when sampling from a population.